complementary angles. So two angles are complementary if their sum equals 90 degrees. So these two are complementary angles, alpha and beta, because this is a right triangle with a 90-degree angle here. So alpha plus beta are 90 degrees. So the sum of alpha plus beta is 90 degrees. Therefore, they are considered complementary angles. And what about supplementary angles? The same thing, but 180 degrees. So supplementary angles. Let's say here's my alpha. Here's my beta. Alpha plus beta equals 180 degrees. They are called supplementary angles. Okay. I had my handout here. Yes, I have it. Here it is. So let's review our formulas and then we'll work on some problems. So remember the definition of tangent. Alpha equals sine alpha over cosine alpha. Cotangent alpha is the opposite. So it's 1 over, the multiplicative inverse is 1 over tangent alpha. We have the sine squared alpha plus cosine, squared alpha equals 1. And we have 1 plus tangent squared equals secant squared. So notice that tangent is with secant. And 1 plus cotangent squared equals cosecant squared. Cotangent with cosecant. So these are the most important trig identities. And the cofunction identities, I'm just going to write 2 of them. As you know, there are 6. So sine alpha equals cosine pi over 2 minus alpha, and vice versa. Cosine alpha equals sine pi over 2 minus alpha. But we have the other 4 as well. 2 more between tangent and cotangent, and 2 more between secant and cosecant. Okay, so I'd like to open the book now. Where is my book? Here it is. Okay. Here it is. So, okay, so it says that I'm signed out, so I may have to, hopefully not, but we'll see. Okay, so how can I be signed out in the middle of my lesson? I have no idea. Okay, so in here, I would like to look at find the value of the 6 trigonometric functions. We are trying to practice the definitions of the trig functions. So feel free to choose anything from here. Anything you want. I selected 20, but we don't have to select 20. We can select anything. You choose. We can start with 20 and we can choose something else.
Start with 20.
Okay, perfect. So let's start with 20. And 20, we have a right triangle, of course. We have the hypotenuse, which is the square root of 5. We have one leg, which is 2. And we have that acute angle at the top, which is, okay, I see there is a chat. Is it for me? 12. Okay, so we're going to look at 12 afterwards. Perfect. Thank you. Okay, so they're asking us to determine the values of the trig functions. So we do have to determine this leg, but there is no problem because we have the Pythagorean theorem. Again, please, one leg squared, I'm going to call it x, one leg squared plus the other leg squared equals the hypotenuse squared. Saying a squared plus b squared equals c squared means nothing. Why? Because you have to tell me what is a, you have to tell me what is b, you have to tell me what is c. Right? You have to say, well, c is the longer side, but it's much better and easier to say a leg squared plus the other leg squared equals the hypotenuse squared. Of course, I will move 4. I get 1. I know that I have to get 2 solutions, but then I will cross it out and I said it's not possible. X has to be only 1 because we are looking at a distance. So then x equals 1. Now we have all sides. We are ready to write all trig functions. Who can give us sine theta, and then cosine theta, and then tangent theta, and then cotangent theta, secant theta, and cosecant theta? To be exact and fair, let me use one of my props. Here's my prop. I'll tell you why in a minute. So can anyone give us sine? Sine theta.
1 over square root of 5.
Excellent. And we will rationalize by the square root of 5, and we will write the square root of 5 over 5. Perfect. Can anyone give us cosine?
Two over square root of 5.
Very good. The adjacent over the hypotenuse. 2 over the square root of 5, which is 2 the square root of 5 over 5, after we rationalize. I don't have to think, I don't want to prevent you from doing that, but I don't need tangent, cotangent, secant, cosecant in terms of the sides of the triangle. I don't need that. We will do it, but I don't need it. Why? Because I know that tangent is sine over cosine. When I divide this by this, I get 1/2. The opposite over the adjacent. When I reverse to find cotangent, I will get 2. Because I divide this by this, and I get 2. And so on and so forth. I'm not saying we shouldn't think in terms of the definition. The definition of tangent is the opposite over the adjacent. But if you divide this by this, you have to get the same answer. If you divide this by this, you have to get the same answer. Because cotangent is the adjacent over the opposite. Secant, all you have to do is multiplicative inverse of cosine. Multiplicative inverse of cosine is the square root of 5 over 2. Cosine, multiplicative inverse of the sine, the square root of 5. And we're done. Again, I'm not preventing you from remembering the definition. I'm just saying this is another way. So tangent, opposite over the adjacent. Cotangent, the adjacent over the opposite. Secant, remember cosine was this over this, so secant has to be the multiplicative inverse, the hypotenuse over the adjacent. Cosecant is 1 over sine, right? So sine is 1 over the square root of 5. So the multiplicative inverse, the square root of 5 over 1. So once you know, again, once you know cosine and sine, you don't have to look anywhere. You can immediately determine the rest of the 4 trig functions, knowing the relationships between them. Tangent is this over this. Cotangent is this over this. Secant is 1 over this. Cosecant is 1 over this. Any questions so far? Anyone? Any questions, please? Anyone? Okay, so let's look at number 12. Number 12. I need a sip of water. Okay, number 12. Where is number 12? Right here. Perfect. So in number 12, theta is right here, and we have 3 and 4. Number 12 is a very interesting situation because 3, 4, and 5 are called Pythagorean numbers. Three, 4, and 5. How come? 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. So it's a very nice situation. 3, 4, and 5 are Pythagorean numbers. 3 squared plus 4 squared equals 5 squared. One leg squared plus the other leg. One leg squared plus the other leg squared equals the hypotenuse squared. Good. So now can anyone give us sine theta and cosine theta? And then we can determine the rest in a blink.
Three over five
Yes.
for sine.
Yes. 3 over 5, the opposite over the hypotenuse.
And 4 over 5.
And 4 over 5. Can anyone give us tangent, cotangent? 3 over 5 times 5 over 4 must be 3 over 4. 3 over 4. The multiplicative inverse of 3 over 4 must be cotangent. Secant and cosecant are 1 over cosine and 1 over sine respectively. Can anyone give us secant? And then cosecant. Oops, equals. Anyone? 1 over cosine.
5 over 3.
Exactly. You meant 5 over 4. So secant with cosine. Cosecant with sine. So secant is 1 over cosine. That's why I reversed 5 over 4. 4 over 5 into 5 over 4. Cosecant goes with sine. What do I get?
5 over 3.
Yes, indeed. Any questions on this type of problem? Is it clear? Are these clear? Yes, no, maybe. Yes?
Can you explain how you get the tangent from sine and cosine again?
Yes. So tangent is sine, yes. Tangent theta equals sine theta over cosine theta. The top is 3 over 5. The bottom is 4 over 5. I divide two fractions. 3 over 5, flip 5 over 4, simplify 3 over 4. Better?
Yes, thank you.
Or opposite over the adjacent. Adjacent over the opposite. Good. Other questions for me, please? Let's take a look. Let's continue with the next set. So let's choose one from the next set and then we move on. Use identities to find the exact value. So here we had to use the triangle. We were able to use the identities. Here they're asking us to use the identities. Use a definition or identities to find the exact value of each remaining. So they're pretty similar, but let's choose one example from here and then from here. Please choose or I will. One, two, three. Okay, I will choose 23. So we have sine theta equals 2/3. Cosine theta equals the square root of 5 over 3. So they're giving us sine and cosine. This cannot be difficult because I know how to find tangent. I know how to find cotangent. I know how to find secant, and I know how to find cosecant. Let's start with this. What do I write? Secant by definition is 1 over secant is 1 over.
Sine.
It starts with S. It cannot be 1 over S. It has to be 1 over.
Oh, cosine. Sorry, I
Yes,
couldn't hear you.
that's okay. So if it starts with S, it's 1 over C. If it starts with C, is 1 over S. Good. So secant is 1 over cosine. What is it? How much is 1 over this?
3 over square root of 5.
Yes, excellent. But I will have to rationalize into 3 the square root of 5 over 5. Multiplying and dividing by the square root of 5. Perfect. Can anyone give us cosecant? Cosecant. It's 1 over.
One over sine.
Perfect. 1 over sine will be?
It's 3/2.
Excellent. Perfect. Tangent is this over this. Once I have tangent, I flip it to get cotangent. So this over this. So I have 2/3 over the square root of 5 over 3. Copy the numerator, flip the denominator. So I have 2 over the square root of 5. So I have 2 the square root of 5 over 5. Please flip this and give me cotangent. Flip this and give us cotangent because this is tangent. Anyone, please? I know everyone can flip this. What is it? Please, anybody?
Square root of 5 over 2.
That's it. So this is sine, cosine, tangent, cotangent, secant, cosecant. Very good. Perfect. Let's move on. Would you like to choose a problem from here? Did we get the idea? I think we should. I think this is another important set of problems.
Can you
Yes?
explain how you got cotangent again, please?
Yes, I flipped tangent. But I didn't want to flip this one because it was rationalized. I preferred flipping this one.
Okay, so that's where I got confused. Thank you.
Because if I flip this one, then I have to rationalize again. Very good question. But if I flip the original one, the raw one, then I don't have to do anything. It's not because I'm lazy, but I have it in front of me. So why would I flip this when I can flip this? Better?
Yes, thank you.
Perfect. Excellent. Moving on. So let's choose here from 25 to 36. Let's not waste time. Let's choose. If not, I will. Please. Okay, I will choose 27. You can choose the next one if you'd like. Cosine theta equals 1/3. Use the definition or identities to find the exact value of each of the remaining 5 trig functions of the acute angle theta. What about the definition? How can I use the definition if I have just cosine theta equals 1/3? Very easy. We're going to do both. So let's do first use identities. And then the second method is using the definition. And I'll explain what I mean by that. Identities. Of course, I don't have enough room. So I'm going to say, see the next page. Okay. So one of the major identities we discussed was that sine squared theta plus cosine squared theta equals 1. Every time I'm given sine or cosine, that's the easiest step. How come? Well, I am given that cosine theta equals 1/3. I will replace this by 1/9. I will move 1/9 to the other side. I will perform the operations. 9 minus 1 is 8. And now I'll take the square root. And I get sine theta equals plus or minus the square root of 8/9. And the question is here, which one do I choose? Because I am given cosine equals 1/3. So there is a minor situation that we have to discuss and we haven't discussed yet. If we go back to the unit circle and we picture the triangle with the central angle, the one that we discussed last time, where this is x and this is y, and this is our theta. We know that this piece is x, but also cosine theta from last class. We know that this is x, I'm sorry, this is y, but also sine theta. So, and I'll say this many times because this is so important. Sine theta, as you see, is measured on the y-axis. It's a y value of this point. So sine is a vertical piece, the vertical leg. Well, the vertical leg is measured here. This is the height. So this sine theta is always measured on the y-axis. If it's measured on the y-axis, angles with the terminal side in the first and second will always have a positive sign. How come? Well, this is positive. And if I have an angle here, the height is still positive. That will be the sign. So first quadrant and second quadrant have sign positive. Of course, when we get to under the x-axis, the sign will be negative. In the third quadrant and the fourth quadrant, sign is negative. Sign is negative. Now let's analyze cosine. Cosine is this piece. But cosine being measured on the x-axis is always positive in the first and the second. I'm sorry, first and fourth. But it's negative in the second and the third. So I cannot choose both. Everything is correct, but I cannot choose both because cosine is positive. Well, if cosine is positive, cosine is here or here. Right? So cosine being 1/3, I could choose both if the terminal side is in the fourth quadrant. But that will not be an angle that fits in a right triangle. So if I'm talking about an angle with the terminal side in the fourth quadrant is way more than 180 degrees. You can say, fine. So your sine could be positive or negative when cosine is positive. But this angle will not fit in a right triangle. So therefore, I can only choose the plus in this situation. But I have to have this analysis, and let's say it again. In the right triangle in the unit circle or any circle, we have a right triangle that is with a central angle at the origin. For any terminal side, there is a point. This point indicates the sine of theta and indicates cosine of theta. Cosine is always measured on the x-axis. That's where it is. It's 0 or maximum 1 or minimum -1. It cannot be more than 1. It cannot be less than -1. The same thing with sine, but sine is measured on the y-axis. It cannot be more than 1. It cannot be less than -1. Because sine is measured on the y-axis, in the top quadrants, sine is positive. In the bottom quadrants, sine is negative. Because cosine is measured on the x-axis, it will definitely be positive on this side and negative on this side. I have to make a decision. We are talking about an angle that fits in a right triangle. So if cosine is positive, the terminal side of the angle can only be in the first or the fourth. But an angle with such a big angle will never fit in a right triangle. So obviously we're talking about the first quadrant. In the first quadrant, both trigonometric functions are positive. So therefore, using identities, I take correctly the square root from both sides. I have plus or minus, but then I have to say no, not plus or minus, but only plus. So then, again, cosine theta equals 1/3, and sine theta, and we have to simplify it, the square root of 4 and 2, so it's 2 the square root of 2 over 3. And this is with identities.